My dear students, I welcome all of you for today's session on design and analysis of algorithms. In this session, we are going to discuss about some of the important problem types. The problem types, what we are going to face in our day-to-day life. Okay, so till previous sessions, we have discussed about what actually an algorithm is. Okay, and we have had a discussion about analysis of an algorithm. So you know what actually an analysis is nothing but investigating how efficient is an algorithm. Means we have discussed what is the minimum space any algorithm requires, or what is the minimum time any algorithm requires. We also had a discussion about efficiency classes. Clear? We had a discussion about order of growth. Clear? We had a discussion about order of growth, that is logarithmic, linear, n log n, quadratic, cubic, exponential, factorial. We had a discussion about asymptotic notations. Big O, always remember upper bound. Big omega, always remember lower bound. Big theta, always remember same bound. Okay. And also we had a discussion about design. Suppose I have designed a recursive or a non-recursive algorithm, how to analyze the efficiency. We had a discussion about mathematical analysis of both non-recursive and recursive algorithms. Clear? So the concepts what we have discussed till previous session was the core of this subject. I request everyone to go through those topics again and again. Get familiar. Clear? And today's session, what we are going to discuss on problem types is a very simple one. Okay? You might have come across several problems, but you need to know some important aspects with respect to that particular problem. For example, I may discuss about sorting problem. I need not have to tell much about what actually sorting. You people know what is sorting, but what you need to know about in depth about sorting, that I'm going to tell you. Okay, so now let me look at the agenda of this session. In this session, I'm going to discuss about three types of problems, namely sorting problems, searching problems, and string processing. Apart from this, we have some of four types, some other types of problems, okay, that we will have a look at, that we will discuss in next session. Clear? So now, coming to first type of problem, that is sorting. So I think everyone know, right, what actually is sorting? I think in your CCP lab, you might have come across something known as bubble sort, or if not selection sort. Got it? They are the solution for the same problem statement. That is rearrange. Means you are given some set of numbers or set of characters or set of strings. You need to arrange them in either ascending order, or you need to arrange them either in descending order. Whatever the order may be, arranging or descending. Just given a set of inputs, set of numbers, set of characters, set of strings, you need to rearrange them in an order, either ascending or descending. Okay, that we call sorting. So now so what is sorting? Rearrange the items of a given list in general ascending order. Okay, until explicitly stated. Okay, by default we are going to rearrange the items of a given list in ascending order. Got it? So now, what actually is here? I said the list what it contains input now. It may be a string, it may be a character, it may be a number. Got it? You need not have to sort only numbers. But in general, we are dealing with, we will, in this session, let me look at sorting a number. Okay. So now, let me in general call input a sequence of n numbers. Okay. Those numbers, let me identify the first number in the sequence given, let it be A1. The second number, let it be A2. Third number, let it be AN. Okay. Next, this is A1, A2, AN. I don't know about the ordering, how they are randomly given. Okay. A1 might be larger or A1 might be smaller. A2 might be smaller, A2 might be larger. AN might be the mid value or whatever it is. So what is an out when I sort, when I asked you to sort the sequence, means you're rearranging and let the output rearranged sequence be A1 dash. Just have a look, okay? Don't get confused here. In output sequence also I have written A1, A2, AM. Input sequence also I have written A1, A2, AN. Okay? Just have a look at the difference. I have in output sequence I have written A1. At the top of A, there's a dash. Okay? Like A1 dash, comma A2 dash. It's not dash, some character. Got it? Next, so what is an output? It's nothing but reordered sequence. In reordered sequence, A1 dash should be less than or equal to A2 dash, less than or equal to 7, so less than or equal, and the last element should be the greater one. Clear? So now, you know what actually sorting is, right? Sorting is nothing but what? Rearranging the given sequence in ascending order by default. Now, what is the need of sorting? Why sorting? Okay, why sorting is necessary? Now, let me tell you. In your result, you might have seen your result sheet, right? You might have seen your, okay. So, in your result sheet, okay, suppose, let me say, in your class, there may be around 65 students. Clear? So when you want, when result sheet is displayed on your in your notice board, and you want to search your result, okay, the row corresponding to your US number, okay. Suppose if it is just displayed randomly, what happens? You need to take some time to locate the row corresponding to your US number. Got it? Suppose let it be say if it is in order of your US number, then it's very easier, very quickly you can locate your row. Got it? So this is one of the application where this is sorting means arranging, displaying the result sheet, okay, in ascending order of your US number. Also, one more means main thing, relocating your row, right, corresponding to your result. So next, what about one more advantage? Why sorting? Said helps searching. Okay, I think you people, you students might have come across binary search in your CC. Got it? So do you think what actually binary search? Binary search is a searching algorithm. Searching means you will be given a list of some n numbers, some n characters, some n strings. Got it? So what you and along with that n inputs, okay, you will be given some something we call a key element. The problem here is that you need to search whether this key element, you need to check whether this key element exists among n numbers, n characters, n strings or not. Got it? That is searching problem. But let me tell you what actually different. Prior to binary search, we had a sequential search. Sequential search means, like what I said, suppose in your result sheet, it is displayed randomly. Okay, Your results are announced randomly. Means it's not ordered according to your USN number. It's randomly displayed. Okay, so you need to locate your USN number. The row corresponding to your USN number takes time. Got it? Means you need to go through from the first row towards the last row in the worst case. Clear? But and there is enhanced searching algorithm after sequential search, that is called binary search. I think you remember binary search. For binary search, it's very faster algorithm. Okay, its best case is a logarithmic. Even the worst case is also logarithmic. Got it? Clear? So how come binary search be faster? The main one more thing, but the requirement for binary search is that the input input sequence of n numbers or n characters n string should be ordered. Got it? So clear. If you just go to the difference between binary search and sequential search. In sequential search, the input sequence need not be in order. Okay. Whereas in binary search, the prerequisite is that the sequence of n numbers or n characters or n strings should be sorted. Got it? So once the sequence is sorted, then you can apply binary search. So binary search is the faster, and the worst case also it's logarithmic. Clear? So why sorting? Sorting helps searching. Okay, and algorithms often use sorting as a key subroutine. Okay, and there's something as sorting key. What actually sorting key means, I'll tell you. Just look at a specially chosen piece of information used to guide sorting. Example, sort student records by names. Okay, I mean, let me say, in your result sheet, okay, what you will observe, it's sorted. In result sheet, each row contains many fields. First one is your USN number, next is USN, your name, next IA and external marks for each and every subject. Finally, status of result, whether pass, fail. Clear? Got it? Means in each row, let me call it's a row, is a record. In record, there are many fields. Okay. So with respect to which field I need to sort your records. Got it? So in your result sheet, you will see each row is in result sheet. You can see records are sorted based on what field? It's based on USN number. This particular USN number, we call it's a USN field, we call a key. Got it? A key is that particular element chosen to sort the records. Clear? So now let me proceed. So let me look at some sorting algorithms. Okay, in detail we'll have a look later. So next, I said in your CCP in first semester, okay, you might have heard about, you might have come across two sorting algorithms: bubble sort, selection sort. I remember. Next, even there is something as insertion sort, merge sort, if sort. These are variety of algorithms, variety of solutions. Okay, for the same problem, that is sorting. We will see in future sessions about this problem. This solution. All the selection sort, bubble sort, insertion, merge, and deep sort are solution for the same problem, that is sort. Okay. So now, how to evaluate sorting algorithm complexity? And let me take you one sorting algorithm first. Then you will come to know this. Okay. So I will look at one sorting algorithm named selection sort. Okay. So in this selection sort, okay, you just remember it is designed as non-recursive. Okay. And while discussing mathematical analysis of non-recursive algorithm, I said you to follow 5 steps. First step is identify what size, and it's very clear here. it's n. And next step is you need to identify basic operation. What is basic operation? The most time consuming operation, the most frequently executing operation. Clear? And when you look at this selection sort algorithm, what operation you will feel to be the most time consuming operation? Whether the first statement minimum equals I, or the last statement that is swap A of I and A of man? Not. In this case, the most time consuming operation, the most frequently executing operation is comparison if A of J less than A of man. Clear? So the comparison A of J less than A of man is a basic operation. Clear? So in selection sort, what we observe, or in general sorting algorithm, what is the basic operation? It's nothing but comparison. So I need to determine number of times this comparison is going to execute. I mean to say I need to determine basic operation count. And that count gives the complexity of this sorting algorithm. So got it. So evaluating sorting algorithm complexity. Evaluating sorting algorithm complexity, I need to determine number of key comparisons. Now, at the start of the session, I said the problem types what we are going to discuss, already you have come across those problems. But I said I'm going to discuss those concepts which you are not familiar. Here, there are two properties. Any sorting algorithms, if we say, okay, maybe selection or maybe bubble, merge, heap, cube, whatever it be. Those sorting algorithms should satisfy two properties. One we call stability, and the other property we call in place. Now, what actually stability means? Okay, let me give you one example. Then you will come to know what is stability. Stability means in general, okay, as you look at a slide, what actually stable means, if I want to call sorting algorithm to be stable, okay, listen, it should preserve the relative order of any two equal elements in its input. See, a sorting algorithm I'll call a stable if that algorithm preserves the relative order of any two equal elements. It should preserve the relative order of any two equal elements in its input. Let me tell you. Let me tell you with an example. Suppose, assume the input sequence is 5, 2, 7, 3, 2. What I said input sequence? 5, 2, 7, 3, 2. I repeat, input sequence 5, 2, 7, 3, 2. And now, when is after applying the sorting, what output I'm going to get? 2, 2, 3, 5, 7. The output I'm going to get is 2, 2, 3, 5, 7. Now the question is that in the output sequence, I got 2 in first two locations. Of course, they should be in first two locations. But the question here is that in the sorted sequence, the first two, what I got, 2 in the first location, what I got, whether is the same first occurrence of 2 in the input sequence. I mean to say, what the input sequence I said, 5, 2, 3, 7, 2, right? So the first occurrence of 2 in the input sequence was 2, right? Which was in the second location. The first occurrence of 2 is in the second location. Remember, the first occurrence of 2 in the input sequence was at the second location. And the same 2 should appear first in the output sequence. Got it? Means that particular 2 which occurred first, that particular 2 which occurred first in the input sequence should appear first in the output sequence. I means in the input sequence there is one more 2 at the last. In input sequence there is one more 2 at the last, but that last 2 should not appear first in the output sequence. If it appears first in the output sequence, then I won't call sorting algorithm to be stable. Got it? So any number of equal elements may occur in the input sequence. Remember, listen, any number of equal elements, any number of equal elements may occur in the input sequence, and their relative position, I mean which 2 comes first, which 2 comes next, which 2 comes last. Okay, this relative position should be preserved in the output sequence also. I mean the 2 that appears first in input sequence should appear first in the output sequence too. The 2 that appears last in the input sequence should appear last in the output sequence also. Then only we are going to see algorithm is stable. We are going to say algorithm to be stable. Got it? So got it. And our sorting algorithm is called stable if it preserves the relative order of any 2 equal elements in its input. So now what about in place? So in place means just now let me come back to algorithm first. Okay. Let me come to algorithm. So in this algorithm, just have a look. What is an input here? It's an array. Array with n elements. Their indices starts from 0 and set n minus 1. Got it? So, but while in the coding part, okay, apart from array, okay, that n elements, I've used some temporary variables, say I, say min, say j, right? Apart from input, of course, it some passes some input. Input n elements occupies some n memory locations. N elements occupies some n memory locations. Clear? So suppose 100 n is 100 memory locations are occupied. N is 1000 memory locations are occupied. But apart from them, apart from this n memory locations, we have some memory locations for I, min, and j. So how many extra memory locations I'm going to use here? Just 3. One memory locations for I, one memory locations for min, one memory location for j. So as suppose if I increase n to whatever the value, in this case in selection sort, if I increase n to whatever the value, okay, but extra memory I require is only 3 memory locations, one for I, one for min, one for j. See, got it? So I mean if n is 1000 also 3 is negligible, right? If n is 10,000, 3 is negligible. If n is a lakh, 3 is negligible. Got it? So if an algorithm I'll call an in place, if it consumes extra less memory, if it consumes extra memory, and that extra memory should be less, like 3 memory locations in selection sort. Got it? So see here, in place. A sorting algorithm is in place if it does not require extra memory. Okay, except a few memory units. Got it? So what is in place? A sorting algorithm is called in place if it does not require extra memory. Even if it doesn't take extra memory also, we call an in place. But if it requires extra memory, there should be a few memory units. Got it? Remember, you might be asked in internal or you might be asked in main exam also. You will be asked, what are the 2 properties of sorting algorithms? So the 2 properties of sorting algorithms are stable and in place. I said you stable, right? If there are any number of occurrences of same elements in the input sequence, their relative position should be preserved in the output sequence also. then only we call sorting algorithm stable. In place means an algorithm should not take extra memory. If it takes extra memory, only few memory, then we call sorting algorithm in place. So this is this algorithm selection sort. Okay, selection sort. What it does? Uh, it selects how it works means in each pass it determines the element to be in that position and it places. Okay, means let me say. Let me tell you in selection set how it works. First, it identifies where is the first smallest element. Where is the first smallest element in a sequence? And then it swaps the first element with that element. In the second pass, it identifies where is the second smallest element. Okay. Then it swaps that second smallest element with the second element with the second position. This is about selection sort. We'll discuss this. We'll analyze this algorithm. We'll trace this algorithm when we come across. Okay, just here I've taken as an example to show about in place. Clear? So clear. Next, I will have a look at searching. What actually searching means? Search. Just now I said about linear search or binary search, or also what you might have done in your result sheet. You used to search where is your row, where is the row that corresponds to your result, right? So that's nothing but searching. Clear? Or in the textbook at the last index, you used to search for some keywords. You will easily search that keyword because they have ordered according to ascending order of alphabets. Okay. What? So now let me tell you what is searching means. You will be given a sequence. Okay. Apart from the sequence, you will be given one element. We call it's a key. Okay. The objective here is that you need to check whether that key exists in that sequence or not. Got it? If the key you are searching exists in the sequence, you say successful search. If the key I'm searching the sequence doesn't exist, I call it's an unsuccessful search. Okay, I mean you'll be given a sequence of might be numbers, might be alphabets, or might be strings. Apart from that sequence, you'll be given an element which I call a key. Got it? And objective here is that I need to check whether this key exists in this sequence or not. If key exists, I need to say successful search. If key doesn't exist, I need to conclude unsuccessful search. Okay. So some examples of searching algorithms. I listed in previous slide some sorting algorithms, right? Bubble sort, selection sort. Similarly, there are some searching algorithms. Okay, there are a lot more, but I listed only two which you have come across in your first semester CC. Sequential search, binary search. I said binary sequential search does not require sequence of inputs to be in order, but binary search prerequisite is that sequence should be in ascending order. Clear? So here is an example of sequential search. Okay, so sequential search, how it works, let me tell you. Okay, in sequential search, what happens? You're given a sequence of n numbers, a of 0 through a of n minus 1. First thing what I'll do, I'll compare key with a of 0. If it matches, I will conclude success. Got it? If it doesn't match, I'll compare this key with A of 1. Now, if it matches, I will exit stating success, else I will compare key with A of. Now, if match occurs, exit stating success. Yes, compare the next subsequent elements. This process of comparing key with subsequent elements continues until the key is compared with the last element. When key is compared with the last element and a match occurs. When a key is compared with the last element and match occurs, exit stating successful search. If a key doesn't match with the last element too, it means key is not in the sequence. Exit stating unsuccessful search. So got it? Sequential search and binary search. So sequential search, you remember, right? I've discussed sequential search in earlier session, and we have seen best case key element is the first element and the basic operation count is 1. Average case key element is the mid one and basic operation count is n by 2. Worst case key element is the last element or key element doesn't exist in the list. Basic operation count is n. Now, in this session, let me discuss one more problem, that is string processing. Okay, what is string processing means? For example, let me take you string. What actually the string I tell you later, but I will give one example. Engineering, ENGINEERING, right? This I'll call one word. Okay, to be in general, I'll call it engineering is a word. In this engineering, I need to check, okay, whether a pattern NEER exists or not. Got it? So you're given a word engineering, ENGINEERING. In this word, you need to search for some pattern NEER exist or not. If it exists, you conclude success. If it doesn't exist, you conclude unsuccess. Okay, so this word I'll call as a string in programming language. Got it? So what does string means? A string is a sequence of characters from an alphabet. A string is a sequence of characters from an alphabet. Here you don't get confused. Alphabet, when I say an alphabet, it needs to be only A to Z. Got it? Okay, even I'll call your USA number, right? It's a mix of numbers and alphabets, right? Okay, even that's USA number is a string. Got it? So in general, okay, a string is a sequence of characters. A string is a sequence of characters, and characters might be an alphabet, uppercase alphabet, or maybe a lowercase alphabet, or maybe a number. Got it? Or any other printable characters. Any other printable characters. Got it? So what actually text string we call? Text string means a string formed using letters, numbers, and special characters. For example, let me say your email ID. In email ID, you will use your alphabets, right? You will use your, someone might be using their year of birth or date of birth along with their name, and sometimes they may use some underscore, dot. These are some special characters. Got this we call text string. Text string means any string formed using letters, okay, numbers, and special characters. Again, string processing. We know what is the string. Everyone knows what is string. You know, right? In general, we used to call a word, but in technical perspective, I'll call it a string. But what is string processing? String processing means, uh, let me call a string. You're given. Okay, let me. What is name of our college? Government Engineering College, Kushalnagar. This is a sentence. Okay, and the given a sentence like this, I may need to search whether some pattern college exists in this sentence. Got it? So you'll be given a sentence and you'll be given a pattern. Okay, you need to check whether the pattern exists in a given sentence or not. That particular problem we call matching, and here we call a string match. So clear with this. So what is string matching? Searching for a given word or pattern in a text. So I think you guys have come to know about string match. Clear with this. So the string is nothing but a word. In some cases, string may be a sentence too. Okay, we can have a sentence too. So how a text string can be formed? Text string can be formed using your alphabets A to Z. Okay, both uppercase, lowercase, using numbers 0 to 9, using some special printable characters. Got a special printable characters like underscore, full stop, so and so. Yeah. Then what is string matching? Searching for a given word, a pattern, a text. So this is about today's session. Okay. And next session, let me discuss some other types of problems. Okay. So clear with this? Clear with the? I hope everyone are clear with the topics we have discussed in this session. This is just an example. Okay. So thank you for listening.